Working with a quadratic function in vertex form. So when a quadratic function is in vertex form, you can use the same concepts from transformations, or sometimes they're called translations, which is essentially the parent graph here is the x squared. And then what the other pieces are telling you is how the function has been changed from the original x squared graph. So the A here is telling you the stretch or compression vertically. And it also tells you if it flips about the x-axis. The value inside the parentheses here, the h, tells you how much the graph is going to shift left or right. And finally, the k value, or the value outside the parentheses, is going to tell you how much the graph is going to move up or down. So let's look at our function here. F of x is equal to x minus 5 squared minus 3. So the square here tells us that the parent graph is still going to be the x squared graph. The x squared graph is the parabola, sort of a sloppy parabola here, and it goes through that center point 0, 0, and it goes in the upward direction. So the a value here, really nothing has changed. You could say that it's a 1, so it's not stretched anymore, and it's also not flipped. So that part isn't going to change. And then we look at the inside. So the minus 5 here actually is going to indicate the graph is going to move to the right. So if it's a minus, it'll be to the right. If it's a plus, it'll be to the left. So it's going to move to the right 5 units. And the minus 3 here tells us the whole graph is going to move down 3 units. So if I start where my original point would be, which is 0, 0, I'll just erase that later. If I take this point and I move it to the right 5, 1, 2, 3, 4, 5, and then I take that point and then I move it down 3 units, 1, 2, 3, that ends up right here. So this is the only point that really matters, so I'm going to erase the other two. So that's our center point, and that's going to be, if you look right here, didn't mean to erase there. If you look right here, that's going to be our new center point. And so it's just going to go up on each side. So our graph is going to look something like this. It's a little bit sloppy. But of course, if you want to get the most accurate graph, then you might want to try to plug in like a few extra values for x, and then just make sure that it all lines up. So this is what our graph looks like. This point here is 5, negative 3. And I just want to identify a few things here. So one thing, if we're trying to find the domain is how much the graph moves left or right. So in this case, you can see that the graph opens in either direction, and what's happening is that it's always sort of slightly moving out in either direction as well. So the domain is going to be all real numbers, or negative infinity to infinity. For every quadratic function, the domain will always be negative infinity to infinity. It's the range that can change. So typically the range for the initial x squared graph is 0 to infinity, because the y values start at 0 and then go up. But what happens here for our graph is you see that we shifted it down 3 units here. So now this is our new lowest point. So the y values start at negative 3 and then they go up on and on, so up to infinity. So the range is negative 3 to infinity. Another value we look at is the vertex. The vertex is that center point. So the part I had in green here, which I'm now circling in on purple. So it's the part of the parabola where it changes its direction. So in this case, the graph goes down and then at that point starts to go back up again. That's what we consider to be our vertex. In this case, it's our minimum value on our graph. and it's going to be at 5, -3. And if you actually look just back up at the equation, even before we constructed the graph, the vertex will always be the first value. If you look at the number right here next to the x value, it's always going to be the same number but opposite sign. So since that's a -5, it's going to be a +5. The second value, or the y value, is going to be exactly the number that you have on the outside of the parentheses, which is -3. And then the last thing we might identify is the axis of symmetry. Just abbreviate symmetry. So that's the line that if we drew the line on our xy plane, if we had a sheet of paper and we folded our graph over that line, it would be a mirrored image on each side. So if I look over at my graph, where that's actually happening here is at this line. So that dotted purple line that I drew, if you folded it over here, it would be mirrored on each side. So that's considered our axis of symmetry, so we just have to write the equation for that. It's a vertical line, so it's an x equal equation, and the line is actually at 5, so it's x is equal to 5. And let's just look at one more. Let's say that we have f of x is equal to -x plus 1 squared plus 7. So let's look for the same things. So that's going to look like the x squared graph. The negative in front is going to make it flip along the x-axis. The plus 1 here, it's going to shift to the left 1 unit. And the plus 7 on the outside is going to move the whole graph up 7 units. And so right here you may actually be able to just come up with your vertex. So the vertex is going to be at -1, because it's the opposite sign of the number in there, comma 7. The second number is the same as what we have on the outside. So the vertex is at -1, 7, and the way we come up with that is because if you start at 0, 0, if you move to the left 1 and then up 7, then that's exactly where we end up with, is that point -1, 7, which is our vertex. So now when I construct the graph, though, that flip, it's like typically, our graph would go up, but because the negative is there, it's going to move in the downward direction. So if I graph it, it's going to look, moving the graph here, that's not what I meant. It's going to go down on either side. Something like this. So the vertex is -1, 7. The domain, remember for quadratic, is always -∞ to infinity. The range in this case, if we look over, the y value looks like the largest y value here is a 7, but then it doesn't go up from 7, it goes down. So it wouldn't be 7 to infinity, it would be the reverse of that, which is actually -∞ up to 7 as being the largest y value. And then finally the axis of symmetry, which essentially just goes right through the middle of our graph. It's going to be right here, this line, which is x is equal to -1.